All right, so this is problem 4 for the baby real analysis problems, and this is taken from J. Cummings' Real Analysis Long-Form Mathematics textbook. So this is problem exercise 14 from chapter 1. Assume that A is a subset of B and both are bounded above. Prove that the supremum of A is less than or equal to the supremum of B. All right, so let's go ahead and do this. So proof. So what does it mean to be a supremum? So we know, um, yeah, so for the supremum of A, we know for all A and A is less than or equal to the supremum of A. And then also if U is any upper bound of A, oh, I guess I'm not sure. Did I already say they're bounded above? I didn't say that they're bounded above. But if U is any upper bound of for A, then sup of A is less than or equal to U. I'm just sort of stating the definition of supremum. All right, so we know A is entirely contained in B. Sup of B, supremum of B, is an upper bound of A, because we know that supremum of B is an upper bound for B, and A is contained in B. Okay, so I kind of redundant here, so I erase this. All right, so for the supremum of A, we know for all A and A is less than or equal to the supremum of A. That just means that's supremum's an upper bound for A. And then we also know that if U is any upper bound for A, so it might be supremum of A or any other upper bound. So for any upper bound for A, we know that the supremum of A is less than or equal to U. Supremum of B, sup B, is an upper bound for A, because supremum of B is an upper bound for B and A is entirely contained in B. So therefore, since the sup of B is an upper bound for A, then we have sup of A less than or equal to sup of B. All right, because that's like our sup of B is taking the role of U in this definition of supremum. So sup and that's pretty much it. That completes the proof. All right, so hopefully that made sense. We had A is a subset of B. Both are bounded above. So I just stated first, well, what does it mean to be the supremum? So for supremum of A, sup of A, we know that for all elements A and A is less than or equal to sup of A. I'm just stating the definition. And then also that if U is any upper bound for A, then the supremum of A, sup of A, is less than or equal to U. Supremum of B, sup B, is an upper bound for A, and that's because supremum of B, or sup B, is an upper bound for B, since it's a least upper bound of B, so it's an upper bound for B, and because A is contained entirely in B, so that's why sup of B is an upper bound for A. So therefore, our sup B is taking the role of U being any upper bound for A on the definition of supremum. And so therefore, sup B, we have it such that sup of A is less than or equal to sup B, since it's an upper bound. All right, so that's it for this problem.